welcome to the third video in tonight's lessons on slope of a line. And we're going to continue finding slope of a line from a table. Again, two methods for using a table. It says the points on the table lie on a line. How can you find the slope of the line from the table? What is the slope? Well, you probably already have an idea in your head how you can find slope. And that would always be using slope formula. So using y2 minus y1 over x2 minus x1, you're sitting here thinking, well, hello, there's 4 points here. Which ones do we use? Well, ladies and gentlemen, if you think about it just very randomly, if we have a coordinate grid here, and you have 0.18 and 0.46 and 0.74 and 0.102, and you have this line that's being drawn, you can find the slope between any 2 points using the slope formula. So it makes no difference which points we use. Just circle them. Okay, I'm going to use this one, and I'm going to use that one. How about that? And then, because we're using slope formula, this point, the first one that I circled, is 0.46. The second one is 0.74. Well, how do I know they go that order? Because x, then y in my ordered pairs. And so it makes no difference which one's 0.1 and which one's 0.2. Makes no difference. So I'm going to call the first 0.46 0.1. And the second one, 0.2. And I'm just going to go right here, and I'm going to say 4 minus 6, because that would be y2 minus y1. And I'm going to say 4 minus 6 over 7 minus 4. All right? Oops. Didn't need to draw that line. 4 minus 6 over 7 minus 4. This is my slope, m. And so 4 minus 6 is negative 2. 7 minus 4 is 3. My slope is negative 2/3. That's it. Using the slope formula, picking any 2 points. Real quickly, I could do it again using different points. And I know our 3 videos are taking up some time tonight. Slope is such an important lesson. I just so appreciate you being willing to persevere and get through it. So we're going to take this 0.102 and we're going to subtract that 0.81. And I'm going to say 2 minus 8 over 10 minus 1. All right. Well, what's 2 minus 8? That's negative 6. 10 minus 1? 9. How do we simplify 6 over 9? Yeah, divide by 3. And that's negative 2/3. Same slope. Makes no difference which points you choose. Now, the second method we're going to use is I'm going to talk about another definition from our first video tonight that we haven't really talked much about, but I said we would. It's called the constant rate of change. Constant rate of change. So as you can see, here's the same table that we had before. And so now, if we know we have slope, and one of the definitions is a constant rate of change, well, hello, let's see what that constant rate of change is. In other words, how do I get from 1 to 4? How do I get from 4 to 7? How do I get from 7 to 10? That's right. I'm adding 3 each time. That is a constant rate of change. I'm always adding 3. And then let's go to the y. How do I get from 8 to 6, 6 to 4, 4 to 2? Absolutely. I'm subtracting 2 every single time. So I have that constant rate of change. And now I just have to write it as slope, saying that it's the change in y. Remember, that was the one on the bottom, negative 2, over the change in x, 3. We get the same answer when we use the table using constant rate of change and finding what is that constant rate of change. So let's go on to a different example and let's try that constant rate of change. I'm sure you could use the slope formula, but let's try that constant rate of change one more time. So looking at our x, how do I get from 1 to 3, 3 to 5, and then 5 to 7? We're adding 2 each time. Okay. And then on my y, 2 to 5, 5 to 8, 8 to 11. I'm adding 3 each time. And so I have to remember that it's the change in y. By the way, you can represent the letter change, or the word change, using a symbol called look like a triangle. The change in y over the change in x, that's something new. You might want to write that down. Change in y over the change in x, we just have to remember to put the y on top. That's 3 over the change in x, 2. So my slope is 3/2. Well, what does a slope of 3/2 mean, by the way? Let's go talk about what that means. It means that if I'm on some graph and I'm at some point, let's say I'm at a point right here, that I would go up 3 and over 2 to get to another point. So from this first point to the second one, I'm going up 3 and running 2. We always run to the right. Ladies and gentlemen, we have some very important notes to understand about parallel and perpendicular lines. So you need to turn to those pages in your notes that you can take a look at them. But we're just going to talk about them right here. We'll look at those pages in class. That's probably a better idea. Let's just get straight to it. So it says that lines in the same plane that do not intersect are called parallel lines. So the blue and the red lines on that graph right there, they're in the same coordinate plane. They never intersect. They're parallel lines. Okay, you already knew what parallel lines were. It says non-vertical parallel lines have the same slope. Oh, so parallel lines, this is what you really want to write, parallel lines have same slope. I know you can highlight that in your text. It's on your paper, but you can write it down. All vertical lines are parallel. So if I have these vertical lines that look like this, and they are vertical, they have the same slope. That same slope is undefined, but they are going to be parallel. All right? They are going to be parallel. Now, ladies and gentlemen, let's take a look at this graph real quickly. Let's take a look at this graph, and let's go to the blue line, and let's find the slope. So I need to find 2 points on the blue line. I have this point right here. I'm marking it right there. That's point 0, 3. And I'm going to go to the next point on the line that I see is very noticeable. I'm going to go to that point right there, which is 2, 4. And I'm just going to count. Up 1, run 2. So I went up 1 and I ran 2. So the slope of this line, this blue line, is 1 over 2. That's the slope. They're telling us that the graph, this line is the graph of that equation up there. Do we see the slope anywhere in that equation? Ah, that's right. It is right there. That might be helpful later. So the slope of this line is 1/2. Let's go to the red line. And the red line, I'm going to start at this point right here, which is 0, -1. And I'm going to go to this next point right here, which is 2, 0. And again, I count up 1, and I run 2 again. So that means the slope of this one is 1/2. And sure enough, we see that slope in the red equation that is different. Y equals 1/2 x minus 1 versus the blue line, which was y equals 1/2 x plus 3. So we have two equations with two lines. They have the same slope. They are parallel. That's what we need to remember. Parallel lines, same slope. Let's go and do one example of that. Which lines are parallel and how do we know? Well, how do we know? They have the same slope. So we're going to go to the blue line. Blue line first. And we're just going to count from point -3, 1 to point 3, 3. I count up 1, 2. And I run 1, 2, 3, 4, 5, 6. So the blue line is 2, 6, which simplifies to 1, 3. Let's go to the red line. Starting at point -1, 0, I'm going to count up 1, 2, and I'm going to count over 1, 2, 3, 4, 5, 6. So the slope of the red line is 2, 6, which again simplifies to 1, 3. And then I'm going to go to the green line. And I'm going to start at this point, -4, -3, and I'm going to count up 1, 2, and I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8. So slope of the green line is 2, 8, and that simplifies to 1, 4. Which two lines have the same slope? You already knew that. The red and the blue line have the same slope, so the red and the blue lines are parallel. This green line will eventually, at some point, somewhere, if we continue to graph on in each direction, would intersect both the red and the blue line. Let's talk about our next lines that we need to know. I'm sorry if I'm going fast. We're going to review this in class. We have a lot to go on these videos. There's 3 of them and they're long. So we're going to talk about perpendicular lines. And again, it says lines in the same plane that intersect at right angles are perpendicular. 2 non-vertical lines are perpendicular when the product of their slopes is -1. So if you multiply the slope of one times the slope of another, you're going to get -1. That's just one definition, and that's the definition that this book gives. Vertical lines are perpendicular to horizontal lines. Okay, that makes sense. If I have a vertical line that goes straight up and down and a horizontal line that goes right and left, they're going to intercept at right angles. They are going to be perpendicular. Ladies and gentlemen, real quickly, I want to give you another definition of slope for perpendicular lines. And that slope means that they are opposite. I like to call it opposite, and they're opposite signs, really. So if one's positive, the other's negative. If one's negative, the other's positive. 2, they're reciprocal. All right, so they're reciprocal, and you know what reciprocal means. So, ladies and gentlemen, let's go over here to our graph and find the slope on the red line. The red line right here, I'm going to find some point. I got this point right here. That point right there is -2, -2. And I'm going to count to another point that I see right there, which is point 0, -1. And I'm going to go up 1 and over 2. Ooh, up 1 over 2. So the slope of that red line is positive 1/2. So I understand. If I'm using the two definitions that they gave us, their products has to be -1, that slope of 1/2 with the blue line, and then, or we can talk about them being opposite signs. So instead of positive, it's going to be negative, and they're going to be reciprocal. So instead of 1 over 2, it's going to be 2 over 1. Let's go to that blue line, and I'm going to find some point on the blue line, and I can see one right here. That's at point 0, 2. And I'm going to go down 1, 2, and over 1 to get to the blue line. So down 2 and over 1. So that means the slope of that blue line, down 2 over 1, if the run is 1, you don't need to write it, that slope is -2. Wow, it is opposite, it's negative. Is it the reciprocal? Is the reciprocal of 1 over 2, 2 over 1? Outstanding, yes it is. And let's see if their products work out. If I take 1/2 and I multiply that by a -2 over 1, what am I going to get? Well, the 2's simplify out. I get -1 over 1, which is -1. One last example before our quick write. We're going to see which lines are perpendicular. And of course, how do we know? We know because their slopes have a product of -1. They're also opposite signs and reciprocal of each other. So we're going to start off with the red line. Red line, here we go, right here at the red line, starting at 2, 5. I'm going to count down. 1, 2, 3, 4. I counted down 4. So the slope of my red line is down 4. My run is going to be 1, 2. And that's going to simplify to -2 over 1, which is -2. Remember, we don't have to write the run. We don't write the run when it's equal to 1. And if you don't see the run, it's equal to 1. All right? Let's go to the blue line. And the blue line, starting at -4, 5, we're going to go down 1, 2, 3, 4, 5, 6. So down 6, so my blue line, down 6. And my run, 1, 2, 3, 4. And my run is 4. How can I simplify that? Dividing by 2, I get -3 over 2. All right. Well, we know that the red and the blue are not parallel, but again, that's not what we're looking for. Okay, we're looking to see which one's perpendicular, and it's going to be perpendicular to this green line. So let's go to the green line, counting from this point -2, 0. I'm going to go up 1, 2, 3, 4, up 4, with a run of, let's take my green, up 4, with a run of 1, 2, 3, 4, 5, 6, up 4 and over 6, dividing by 2, I get what? I get 2/3, and that's positive. Wow. So what do I see? I see right here, I have opposite signs, -3/2, positive 2/3, and I see reciprocal. Instead of 3 over 2, I have 2 over 3. So the blue and the green are perpendicular lines. And if I multiply that, -3 over 2 times 2 over 3, we can see right away that the 2's simplify, the 3's simplify, leaving us with -1 over 1, which is -1, a product of -1. Ladies and gentlemen, I know you're going to have questions. That's okay. You have our last quick write to do, and there's 2 parts. Describe the slope of 2 parallel lines and 2 perpendicular lines. That's 2 sentences, 1 sentence each. And then here's a table. Pause the video. Well, you don't need to do that because I have it written down in the copy I gave you. Find the slope from that table. Ladies and gentlemen, you are awesome. Thanks for all your efforts tonight. I know it's been long. I'll see you tomorrow. Bye.